Your test review is a grade. It's a quiz grade. So when you come in on the day of the test, you'll turn that test review in, or you'll wait till after you're done with the test and you'll turn it in. But as soon as you walk out my door, I consider it late. So, and then, huh?
Like, as soon as we walk out the door?
As soon as, if you don't turn your test review in at the end of class and you walk out this door, it's late.
Oh.
Okay? As for the answer key, I do not post the answer key because it's for a grade. So, what happens is I try to get that test review to you prior to you coming to class so that you can work on it then. And then you can check your answer key against my key, or your answers against my answer key. And then if you're at home working on it the night before the test, a lot of kids will take a picture of it, snap it, send it to me, and say, will you check my answers? And I will check the answers and say, you're good to go. Or you need to go back and look at question number 3 because it's wrong.
But you won't give us the answer.
But I won't give you the answers. Dang. Any other questions? Okay, so physical changes. We left off on Friday by doing a lab over chemical versus physical change. We saw that physical changes do not create a new substance. And some examples of physical change is cutting, dissolving, okay, so dissolving salt in water, that's just a physical change, melting, evaporating, crushing, freezing, or any kind of phase change. Freezing is a phase change, melting is a phase change, evaporating is a phase change. Any type of phase change is just a physical change. It does not create anything new. Does anybody have a question on physical change? Do you need a second to write these notes down before I go to the next slide? This class is way more focused than the class prior to. That's a matter of opinion.
Oh, so you don't like this?
Just kidding. Okay. Next. All right, a chemical change. A chemical change, we will have a new substance being formed. One or more. And they're going to have different properties than what they had before they mixed. We will have evolution of light and heat, which means we will create light or heat in this chemical reaction. Which means that we're going to see temperature change or flames. A production of gas, we saw that several times on Friday. Formation of a precipitate. Color change. So, evolution of light and heat. So that's kind of two right there. You can have light without heat. You can have heat without light. Or you can have both of them. So that's kind of two. So there's really five things that will tell us that a chemical change has happened. Light and heat, gas, and when we have formation of gas, that produces bubbles. Precipitate. And a precipitate, what happens in a precipitate is the following. Say we have two liquids here. Okay, one is red and one may be a clear liquid. But what happens is if we take those liquids and we put them into another tube, we may get a liquid, and then at the bottom of there we will get a solid being formed. Okay, so at the bottom, two liquids will make a liquid and a solid. And that's a precipitate. Just a chemical reaction that does occur or does not occur. Yes?
It says the production of gas, so when you heat up pan of water, that produces gas technically. So
It does. So production of gas, but is it a new substance? So it's not really a new substance when we're heating it. That's just a phase change.
okay, so even though it's a production of gas, it's not always.
Right. It does not have to be. Okay. Color change. And so some examples of chemical changes around us: burning fuels, iron rusting, the Statue of Liberty being green, food spoiling, the leaves changing colors in the fall is a chemical change. And then deposits formed in your pipes, those calcium deposits that might be formed in pipes. Okay, and here is one of those examples of a precipitate. This was two clear liquids. They dumped them together, and we ended up getting a white solid down here. Okay, sometimes you'll have two clear liquids, you'll get yellow solid at the bottom. Just depends, and we'll see that throughout the year as we go through class. Chemical change in the glow sticks. Okay, there's a chemical change going on there. Any questions? All right. So let's go over these. Is it a chemical or physical change? And some of these I'm iffy on. Boiling water, chemical, physical. Physical. Digesting food, chemical, physical. Chemical. Soda going flat. I would say it's physical. All we're doing is having the gas come out, and so now it's still soda, it just doesn't have the gas in there anymore. Shooting a rubber band. Grilling a hamburger.
No.
Chemical.
Burning stuff.
Adding sugar to your tea. Adding lemon to your tea. Mowing the grass. The smell of perfume as it wafts across the room. Candle wax melting. Physical, but burning a candle is chemical. Okay? So if you have a candle or you have one of those Scentsy warmers, wax warmers, the wax warmer, all that's doing is just warming and melting it. And that is a physical change. Whereas if you have a candle, you have that heat, that flame, and that's actually, and that wick is burning and there's something going on in there. Okay? Breaking glass. Making cement.
Don't you just like put in that little circle thing?
I mean, you're just mixing water, and so you're putting water in there, and I'm not sure. It forms a solid. Y'all want to go with chemical? Lighting a match. LED display. Light emitting diode.
But it's just heat traveling along the wire.
Like chemical. You already know.
I would say it's physical.
Hey, why? My first one. How is that?
I mean, it's like you're turning your lights on, your lights off. All you're doing is your electrons are just traveling, and then you stop it, and then it's still the same thing, right? The LED doesn't actually change.
There's no real chemical reaction.
What about a firefly glowing in the dark? Snow disappearing. Bleaching your hair. Turning on a light bulb. Physical. Milk going sour. Shooting of fireworks. Chemical.
Could you argue that in order to create the electricity, you have to burn coal, which is a chemical reaction?
I think you're getting too far out there.
Because we don't use coal. Wait,
What do you mean?
Discharging fire.
Discharging a firearm? That's a chemical reaction.
Yeah.
It would be because you're burning a bunch of gunpowder.
What?
Yeah.
And then you're activating a
Well, you burn it on a power plant.
Sorry.
Underneath,
Okay. So we talked about mixtures. Sorry to be yelling in your ear. We talked about mixtures. So what we want to do, Ruffin and Trent, is we want to be able to take a mixture and we want to be able to separate it into its component parts. And there's several ways that we can do this. So I would know how to do these, and I would know what they are, be able to describe them. So the first one is called decantation. Decantation. And that is to pour a liquid from one container into another, leaving behind a heavier liquid or a solid, whatever was left in there. So when we decant something, are you going to talk about heterogeneous or homogeneous mixtures? Heterogeneous. This has going to be a heterogeneous. I also call this a dirty technique. In the lab, you have clean techniques and you have dirty techniques. This is called a dirty technique because it's really quick and easy, but you can make mistakes. Do we fully get everything off of what's left behind? We're going to leave something behind, okay? What happens if you are being in a hurry and you accidentally pour too much into here? What do you have to do?
Nuclear explosion, you'll die.
You have to start over, right? Because you've now got some of your undissolved solid over here and you've got to start it all over. Okay? So here is oil and water. We have a heavier and a lighter liquid, and the heavier liquid is on bottom, and we decant off or open this valve, and out comes the water, and then we watch, and close the valve as soon as we see all the water is gone.
What if you
Have a little left. That's why I call it dirty, is because there's still something left in there. Okay. Now this one is going to be a lot cleaner than this one, just because. Any questions on decantation? Everybody good? All right. Distillation. To distill something is the evaporation and subsequent collection of a liquid by condensation as means of a purification. So this we can do with a heterogeneous or a homogeneous substance. So you have a, and I know this sounds disgusting, but you have a piece of meat, say liver, all right? So I used to work in a lab, and I used to do liver cancer and liver disease research. You get a liver in, and you can take the liver, and you can smush it up till it's all just nice and little pieces. And then you dump the liver into your flask, and you add some acid in there, which will help start to dissolve part of whatever's left over in that liver, to get it more of a slurry mixture, less chunky. So then what you do is you boil it. And as you boil it, what happens is the things in the liver are going to boil at or have different boiling points. So at a certain temperature, fat's going to boil before protein does. And the fat is going to evaporate or vaporize, and it's going to start to come up into here. And then it has nowhere to go because we've got a stopper here. And so it's going to go down this flask, this arm. When it gets right here, there is cold water, a water jacket outside of it, and it's running. And as it's going through, the cold water does what to that vapor? It condenses it. It cools it down. And so what happens is now that vaporized fat is going to come over here, and now it's going to be a liquid and drop down into here. And so we can separate our protein from our lipids, our fats. You can do this with alcohol. If you have a certain alcohol you have a 70% alcohol and you need it to be 90%, what we can do is we can take off some of that water. Water is going to distill or boil at a different temperature than alcohol, and the water will come up, and then it'll condense, and then we can collect our water or our alcohol. Okay, so really cool things that you can do in there. Probably, if you take chemistry in college, you'll do this. You'll definitely do it in organic chemistry. Any questions on separation techniques of distillation? Next, this is a cleaner version of decantation. This is filtration. So what happens is now we've got this filter right here in this funnel, and this filter is going to capture particles. If the particle is too large to go through the filter, then it's going to be left behind. And then what we can do is we can take the mass of that solid or whatever's left behind, and we can determine how much solid was in our substance. And we will do this too in next semester. We will actually make some copper in here. So this is our clean version. So this is cleaner than decantation. Oh yeah, very clean. Cleaner than decantation, and this is going to be with our heterogeneous mixtures. So we've gone over decantation, filtration, and the other one was, I already forgot, distillation. Is it hot in here?
Sorry, that's me.
Who said that?
You're welcome.
Again, matter of opinion.
No, his hair is looking pretty.
It can be homogeneous, but it can be heterogeneous. Like I said, you had that fat, the piece of liver. Okay, next. Evaporation or crystallization. So here, instead of, we can take salt water and we can distill it, or we can take salt water and we can evaporate it. Now, what's going to be the big difference between the distillation versus the evaporation? Longer? What's happening to the water when we evaporate the water off in crystallization?
All of it.
It's gone. We can't collect it, right? Whereas if we're talking about distillation, we can actually collect our water, and we can use that for whatever purposes we need. Okay, so evaporation, crystallization. You did this with maybe borax crystals when you were in middle school, or maybe you make the rock candy, the sugar candy.
What? What middle school did you go to? That sounds fun. My middle school teacher taught me about land and sea breeze.
Oh,
Never took those.
I had her too.
So what we do here is you can either do it via natural, by not applying any heat and letting nature take its course, or you can add some heat there to speed up the process and then collect those crystals, salt, sugar, whatever's left behind. Okay, so evaporation, crystallization. We have filtration. Trent, tell me another one. Evaporation, crystallization, decantation, and what's the last one? Distillation.
Woo! You didn't see that coming. That we weren't paying attention.
Any questions? And we have one last one. I would say this is clean. It's just longer. Yes.
Is it the header?
Oh, thank you. Good question. It would be more of a well, could be homogeneous or heterogeneous. It just depends. Like sand and water, you could eventually. So it could be both. You could do this with both. No, it's just added information I want you guys to know. All right, last one is called chromatography. What you do with chromatography is you're going to separate out those different mixtures. So you can take a marker and you can separate it out into its primary colors through chromatography. And chromatography is going to be based on the size of the particle or on the charge of the particle. And this is going to be for a homogeneous mixture. Okay, so what happens is you have this, whatever you have, your substance, your mixture. Here you have a gel or something that has one phase, and it's going to, your mixture is going to move down, this is through gravity, move down through this column. And it's going to start mixing out, or coming out into different layers, different areas. So the smaller you are, the faster you're going to come out of this tube. All right? If you're really big, then you're going to be left behind up here. Yes. We're not going to do this one. We're going to do more this one right here. Where here you'll put a mark of whatever you have, a dye or whatever. And then it will have a solvent here, and we'll see how far it moves up. And different solvents are going to make it move at different rates. We are. I think that we're going to do this in lab.
But we have a lab like
try to, but sometimes.
I was just saying no.
But I think this one I'm going to actually try to make it as a write-up. Because this one's pretty cool. We're actually going to look at the different dyes between M&M's and Skittles.
Don't put it on Friday.
All that. You say don't do it on Friday?
Yeah. Why? That makes us not have to do
Oh, well,
The only thing that sucks, yeah, we have a rally, pep rally on Friday too.
You said it sucks?
I love
Because it's bad because my classes are on different times.
Ours is much shorter.
But this one is fine. It's just my best class is my study hall.
Yeah, I'm in it.
No, I don't have a study hall anymore. Remember?
You don't have a study
Where am I supposed to go again?
Huh?
Where's the room?
Not this hallway, but the next one.
Is it clean?
This is very clean. Yes. This they do with like DNA and stuff. All right. Any questions over separation techniques? So lastly, what we are going to end this unit on is density. And density is mass divided by volume. Density, is it a physical or chemical property?
It's like the heart.
It's a physical property. Okay, is it intensive or is it extensive? Does it not depend on matter, the amount of matter, versus extensive, it does depend on the amount of matter.
No, it's intensive because you said the thing about the.
It's intensive. The thing about the ruler, take a ruler, break it in half, take it in half, break it, keep on breaking it. It's not going to change. So, and again, remember density is mass divided by volume. If I increase my mass, my volume is probably increasing too. It's a ratio. It's not going to change. So you are going to do a worksheet on density. It will be due tomorrow. 1, 2, 3, 4, 5. You have 4 different substances. You have water, So go to the part where you have the density of water.
Thanks.
Okay, the density of water. So what you're going to do is, on all of these, so we have water, a mystery liquid, we have gold, and we have fool's gold. You need to graph these. So when we graph these, we are going to have our graph set up, and we are going to graph mass. Mass is on the y-axis, and volume is on your x. So mass and volume. Now, this, so mass is on the, is y, volume is x. I have not given you any, when you're massing or when you're graphing this, I've just given you a blank graph. You're going to set that up however you want to set it up. Okay? Yes.
So, you said mass was the dependent? Or the independent? You said mass was independent?
Mm-hmm.
Okay, just checking.
Okay. So you need to come up with however you want to do your graph, how you want your measurements to be. Mass or density is mass divided by volume. Density is also, when you're graphing these, is equal to your slope. Okay, so it'll say, what's the density? Which is your slope. And slope is what? Rise over run. Okay, it'll talk about what's the overall pattern. Is it increasing, decreasing? What's the relationship? Is it direct or indirect? What's the difference between direct relationship and indirect? Direct relationship is when one goes up, the other one goes up. All right? Indirect is if one goes down, the other one goes up. They do the opposite things. Are there any questions as to what you are doing?